SAS Event Stream Processing, or ESP, lets you detect meaningful patterns and act on them in real time as data flows through your systems. This demo highlights key capabilities using example projects provided in the software, so you can experience the power of ESP without needing to build from scratch. If you have access to SAS Event Stream Processing, I encourage you to follow along with me. SAS Event Stream Processing includes essential tools like Event Stream Processing Studio and Event Stream Manager, along with helpful resources for getting started with project creation, deployment, and visualization. From the SAS Viya home screen, select the Applications menu and choose Design Streaming Projects under Streaming Analytics. SAS Event Stream Processing Studio opens with the project list page in focus. This is your starting point for managing and accessing ESP projects. From here, you can create, edit, or delete projects, import or export a project and package files for sharing, and view project metadata. If you're new to ESP, a helpful place to start is to click View Example Projects. The SAS Event Stream Processing examples provide a collection of pre-built projects that demonstrate how to use key features in the platform. These examples cover common use cases such as filtering events, processing video, applying analytics, or detecting patterns. You can open and explore these examples directly in ESP Studio to see how a complete project is structured, then modify them to fit your own streaming data needs. Samples are easy to install. Find Lua Parse, which is a project that uses Lua code to parse input JSON data and separate it into multiple events. Change the project name to Lua Parse Test, then click Install Example. Examples are distributed using project packages. A project package is a way to bundle all the components of an ESP project into a single portable file. Click the project package icon to view the contents. A package can include project XML, custom code, analytic files, metadata, and more. Basically, everything your project needs to execute successfully. To learn a bit more about the data in this project, expand test_files. Then right-click Lua Parse JSON Simple.csv and select Open File. This file includes one row of JSON code, which captures 3 different events, including a device ID, sensor ID, and a value. Click Close. This sample project includes 2 windows. The source window is the entry point for data flowing into your project. Think of it as the front door, where events or records first arrive before being processed, transformed, or analyzed by other windows in the model. Currently, the project is set up to receive data from the test file we examined. In a true production-ready project, the source window would connect to a data source with continuous input. The Properties pane on the right is where you configure all the details that tell ESP what kind of events the source will receive and how it will receive them. The Output schema defines exactly what data fields the window will produce for downstream processing. In this example, we have a unique ID assigned to each row and sensor info, which captures the full JSON string. Next, let's look at the properties of the Create Multi window. This is a Lua window that receives the data passed along from the source. Expand Lua settings and note that there is a Lua program that parses each JSON string to create separate variables. Select Output Schema to see the corresponding fields and attributes generated by the Lua code. We can easily see this project in action by saving it, then clicking Enter Test Mode. Test Mode provides a powerful interactive testing interface that helps validate, troubleshoot, and fine-tune your streaming logic. On the left, you can browse the schema for each window and apply sorting or filtering. This can be helpful for debugging and examining specific scenarios. Click Run Test to kick off the project. For each window in your project, like sources, filters, or calculations, you can open a live output view. You'll see the data records as they pass through that window, so you can verify that your logic is behaving as expected. A built-in log viewer displays system messages, errors, and warnings. You can quickly identify misconfigurations, missing fields, or schema mismatches. Let's take a look at our results. The project runs using the test data viewed earlier. The Source tab shows the single row read with the ID and sensor info fields. Create Multi shows 3 events were created by the Lua program. The JSON string was parsed to assign values to the fields defined in the output schema. Notice there are multiple events for the same device ID 1000. What if we want to summarize values by device? Click Stop and close the Test tab to return to the project window. Select Windows to view the many transformations, utilities, and analytics windows that can be integrated into the project for more complex processing. Drag the Aggregate window onto the canvas and connect it from the Create Multi window. The first step to configure this Aggregate window is to define the schema. Select Output Schema and click Import All Schema Fields to duplicate the fields from the upstream window. The default aggregation action keeps the last value in each field by ID. To modify these settings, click Edit. Select the ID row, then click Delete, and repeat to remove sensor ID from the schema. Select the key checkbox for Device ID so that values will be summarized for each unique device. Then change the aggregate function for value to ESP_A AVE and confirm the parameter is value. Change the field name to value AVG, then click OK. Let's save the project, return to test mode, and start the test. Notice Create Multi still includes 3 events, but the Aggregate tab has just 2 events, one per unique device with the calculated average of value. Once a project is built and tested, you can save a version of it to capture a snapshot of your project at a specific point in time. This creates a stable, immutable, known good configuration, which is ready to be deployed. This helps teams move forward from experimentation to production with confidence and control. Begin by clicking New Version. You can add optional tags and a description, then click OK. Version 1 is created. The next step is to promote version 1 to test. Once you've promoted a version to test in Event Stream Processing Studio, then you're ready to create a deployment, which is the actual step that pushes your project version to a running ESP server so it can begin processing real-time data. To deploy and monitor projects, go to the Applications menu and select Manage Streaming Analytics. SAS Event Stream Manager opens. Here's how the deployment process works. Click New Deployment. Type Lua_parse_prod in the name field and click OK. Then click Load and Start Project. Select the Lua Parse Test project and confirm the version is version 1, the one promoted to test in ESP Studio. Here you can configure the image, including the target ESP server, the deployment type, and adapters and connectors to ensure all required data sources are accessible. Keep in mind that our project is only reading the test data with 1 line and 3 events, but typically the source of a production project would receive a continuous flow of data. Deployment settings allow you to define requested memory and other resources. That's it. Just click OK, and the project is deployed and running on live streaming data. We've barely scratched the surface of what is possible with SAS Event Stream Processing. I encourage you to visit the Help menu to learn more through the Help Center, tutorials, and SAS communities.